Run the code online or download from codegive.com, link in the description below. Title: Understanding Float Power in Python, a comprehensive tutorial. Introduction. In Python, the operator is used for exponentiation, allowing you to raise a number to a certain power. When dealing with floating point numbers, this operation can sometimes lead to unexpected results due to the nature of floating point arithmetic. This tutorial will explore how float power works in Python, potential pitfalls to watch out for, and best practices to ensure accurate results. Understanding float power. Float power refers to raising a floating point number to a given exponent. In Python, this is typically done using the operator. For example, this code calculates 2.5 raised to the power of 3, resulting in 15.625. Float power pitfalls. Although Python provides convenient ways to perform float power calculations, it's essential to be aware of potential pitfalls, particularly related to floating point precision. Due to the binary representation of floating point numbers, certain operations may not yield exact results. Consider the following example. Here, raising 0.1 to the power of 3 should theoretically result in 0.001. However, due to floating point precision issues, the result is slightly off. To mitigate such issues, it's crucial to be mindful of rounding errors and precision limitations when working with float power operations. Best practices. To ensure accurate float power calculations, consider the following best practices. Use decimal module. For precise decimal arithmetic, consider using Python's decimal module, which provides more control over precision and rounding. Round results. When dealing with floating point results, round the output to the desired precision to mitigate rounding errors. Avoid exact comparisons. Instead of comparing floating point results using equality, consider using approximate comparison techniques, such as specifying a tolerance level. Understand floating point representation. Familiarize yourself with how floating point numbers are represented in binary to better understand potential precision issues. Example using decimal module. This code utilizes the decimal class from the decimal module to perform precise arithmetic, yielding the expected result of 0.001 without any precision issues. Conclusion. Understanding float power in Python is crucial for accurate mathematical computations, especially when dealing with floating point numbers. By being aware of potential pitfalls and adopting best practices, you can ensure reliable results in your calculations. Remember to consider precision, rounding, and the limitations of floating point arithmetic to avoid unexpected outcomes. ChatGPT.